If we're asked to find the rational equation that satisfies this graph, then the first thing I always do is just kind of look at the shape itself. So it looks like what's happening is I have a horizontal here, a horizontal asymptote of what it looks like. And the reason I think it looks like that is because as x goes to negative infinity, I seem to be getting closer to the x-axis. And as x goes to positive infinity, it seems to be going close to the x-axis. So that tells me that it looks like we have a horizontal at y equals 0. Now, going backwards, if I have a horizontal at y equals 0, what does that tell us about the degree of the numerator and the degree of the denominator? So that tells me that the degree of the denominator, so we'll call that, because we have p of x over q of x, the degree of q of x is greater than the degree of p of x. So that's what it tells me. The other thing that I look for is it looks like I've got this vertical asymptote at x equals negative 3, and I have this vertical asymptote at x equals 2. Where do the vertical asymptotes come from in the rational functions? Do they come from factors in the numerator, or do they come from factors in the denominator? They come from factors in the denominator. So that tells me that I must have had a factor in the denominator of x minus 2 and an x plus 3. So far what I have in terms of my rational function f of x, this is going to be equal to my denominator of x plus 3 and x minus 2. That's what I have so far. Now, I don't know if those will have powers other than 1, but I do know that those have to be in the denominator. Now I look to see whether or not I have an x-intercept, and what is it? So I erase this so I can see the x-intercept. And I have an x-intercept. It looks like it's crossing right there at the point negative 1 comma 0. That is my x-intercept. Where do my intercepts come from, the numerator or the denominator? They come from the numerator. So if I would have had x minus 1, then my factor in the numerator must have been x plus 1. So now I just need to check to make sure that this satisfies that graph. One of the things that's the low-hanging fruit is the degree of the denominator larger than the degree of the numerator? So if we're looking at the degree of the denominator, this is a degree 2, and what is the degree of this one? So is this satisfied? Yeah, so that's satisfied. Now all I have to do is I'm going to do a sign chart to make sure that what I think the rational function is satisfies that graph. So I'm going to do a sign chart, and so I have all of my factors both from the numerator and the denominator. And my numbers that I choose in my sign chart are what I think the vertical asymptotes are and what my x-intercepts are, strictly left to right. So x equals negative 3, x equals negative 1, x is equal to 2. So I need to choose something in this interval, which is negative infinity to negative 3. What do you all want to choose? Okay, so I'm choosing negative 4 in here. So I put negative 4 into my first factor, I get negative. I put negative 4 in my second factor, I get negative. I put negative 4 in my third factor, I get negative. So is this above or below the x-axis? It is negative and it is below. So my next interval is between negative 3 to negative 1. What do you all want to choose in that interval from negative 3 to negative 1? So I'm going to choose negative 2. If I put negative 2 in that first factor, is that positive or negative? Put negative 2 in the second factor. Is that positive or negative? I put negative 2 in that last factor, positive or negative. So is that region positive and above or negative and below? My next interval is between negative 1 and 2. What do you all want to choose in that interval? So I'm going to choose 0. So then I'm going to put 0 into there. If I put 0 into my first factor, is that positive or negative? The second one? Third one? So is this positive and above or negative and below? I choose something in that last interval between 2 and infinity. What do you all want to choose? So I put 3 in that first factor. Is that positive or negative? Second one? Last one? Is this positive and above or negative and below? So now let's see whether or not that's true. In the interval between negative infinity and negative 3, was I below the x-axis? In the next interval between negative 3 and negative 1, was I above the x-axis? In the interval between negative 1 and 2, was I below the x-axis? My last one, between 2 and infinity, was I above the x-axis? So then this truly is my function that I have. Okay? Do you want to try another one? Yep. Now when you put it into WebWork though, you do need to make sure that you put it in as f of x is equal to x plus 1 with parentheses, division bar, and now you're going to have one set of parentheses to tell you that x plus 3 and x minus 2 are all in the denominator. So you're going to have to do those double parentheses in there. Do you want to do another one or are we good? Slant asymptote? Okay. So let me go out and grab a slant. Here it is, in all of its glory. Yep. So my rational function on this one, let me see if I can make this smaller. There we go, not working. Okay. So my rational function is, see, I can't seem to make this smaller. All right, I'll just move it over if I need to. So I have my vertical asymptote. I can see that fairly straightforward. It looks like as x goes to 0 on the left and right that I'm going either straight up to infinity or straight down to negative infinity. So I know that this x is equal to 0. So where does that come from, the numerator or the denominator? So that comes from the denominator. I also know that right here I have an x-intercept. I have an x-intercept of 1, 0. And does that come from the numerator or the denominator? The numerator. So this is x minus 1 as a factor. Now, what also seems to be happening is I have a slant asymptote. And so I've got to figure out, looks like I got some kind of slant asymptote. I need to figure out what the best slant asymptote is. So if I start right here at 1, it looks like a good place to start because it looks like the distance from here and the distance from here looks to be about the same. So I'm gonna start there. That's a good place to start. So if I do a slope of say 2, so up 2 over 1, I'd end up here. And up 2 over 1, I'd end up here. And if I thought that's what my graph looks like, I'm actually moving away from that, right? that this part of my graph is moving away from that line, so it's not going to be that line. So if I think maybe the graph slope is, say, up 1 over 2, then I'm actually hitting the graph there, so I'm not going to use that one. So what I think it might be is up 1 over 1, up 1 over 1, up 1 over 1, etc. And then also going down 1, back 1, down 1, back 1, down 1, back 1. So that's what I think the graph slope may be. So let's see if I can make this line work out. Look at that. I'm so proud of myself. The best line I've ever drawn. Yeah, so I've got this part of the app that allows me to, if I see, this is what it looked like. That's what the line looked like. Do you see how bad that is? But it recognizes it as a line. So, I'm pretty excited about that. So that's what I think the equation is. So I think I've got the slant asymptote of, oh, now this stupid thing works. So I think I've got the slant asymptote of y is equal to x plus 1, right? That's what I think it's equal to. So I come over here, and I know that when I take x and divide it into my numerator polynomial, that I have some numerator. Remember, this is px over qx. When I divide this into p of x, I need to have x minus 1 come out, or x plus 1 come out. I need to have x plus 1 come out. I know that has to happen, okay? And I also know that part of my polynomial here, p of x, has to be x minus 1. Part of the factor has to be x minus 1. Oh, I haven't. Oh, look at that. It actually gives me the other x-intercept, so I didn't have to do all the other stuff. But if I didn't have another x-intercept, then I'd be able to find it this way too. So this one works out, so I don't even have to do any of that. So then my other x-intercept is x plus 1, and then all I have to do is just make sure that this works out. So I have x squared minus 1 over x. Is the degree of the numerator larger than the degree of the denominator? Yep. So this is what I think it is. I do need to check my division here. So I have x divided into x squared plus 0x minus 1. So if I divide x into there, I get an x squared plus 0. And then I subtract this off. So minus minus. And I end up with negative 1. Does that work out? Does that work out? How many times does x go into negative 1? 0 times. So is this my actual... Does that work? So I have this other x-intercept. I have this x-intercept and I have this x-intercept. This other x-intercept is negative 1 comma 0. That means x minus or x plus 1 must have been a factor of the numerator. Oh, is it negative 2? Helps if I can read my graph. So that's going to make this so much easier. So let's do this. Thanks for catching that. So then I end up with x squared minus or plus x minus 2. So then let's go over here and do that long division. X. So this one's actually pretty straightforward, but I will do a long division one that isn't. How about that? Okay, so I asked myself how many times does x go into x squared? It goes on there x times. So I get x squared, and I subtract that off, bring down my next one. It goes in there one time, bring down my next one, -2. So here is my slant asymptote. And does that match what I think it is?
Yes.
Yep. All right. So a long down of long division, a rundown of long division. So Matthew, did that help?
Yes.
Okay. So let's do a rundown of long division. Man. Yeah, and if I can read the graph correctly, I can intercepts correctly. Okay, so I have, say I have this polynomial x to the 4th plus 2x3 plus x squared plus x minus 7, or minus 1. And I am divided by x squared plus x minus 1. Because otherwise I would do synthetic. If this thing wasn't nonlinear, I wouldn't do long division. So I have x squared plus x minus 1 divided into x to the 4th plus 2x cubed plus x squared plus x minus 1. So what I need to do is I need to have this x squared match this x to the 4th. Coefficients need to match and the powers need to match. So what do I need to multiply x squared to get x to the 4th? So I'm going to multiply by x squared, so I put it over the x squared term. So I do x squared times this x squared, this x, and this -1. X squared times x squared gives me x to the 4th. X multiplied by x gives me x squared multiplied by x gives me x to the 3rd. And then x squared multiplied by -1 gives me -x squared. Now, I subtract this off so that it changes the signs of my polynomials. So those x to the 4th cancel out. And then I drop down, so I have 2x cubed minus 1x cubed is just x cubed, plus 2x squared plus x. How do I get my x squared here to match this x cubed? Multiply it by x. So plus x. So x times x squared is x cubed. X multiplied by x gives me x squared. And then x multiplied by -1 is minus x. So then I subtract this off, so my signs change. And when my signs change, I'm going to end up with the x cubes canceling out, leaving me just x squared plus 2x minus 1. So I need this. I need this x squared now to match that x squared. So what do I need to multiply by? So plus 1. And so I end up with x squared plus x minus 1. And I subtract this off. So my signs change. And I am left with just x plus 0 or just x. So those cancel out. I did actually a pretty good job of almost finding one that divided it nicely. That's not too bad. I almost found one randomly. Okay, so what I end up with is, had this been a rational function up here, right? Had that been a rational function, then I would have had a graph which had a quadratic shaped asymptote. So let's actually go and graph this. Yes. Yep. Okay, so what did I have? I had x raised to the 4th. What else do I have? And then what would I divide in by? So that's what the graph looks like. What was the quadratic we ended up with? Nope, we don't need to do the remainder. So let me do this in projector mode. So that's our graph. So here's our graph. You can see our quadratic shape. Actually, let me do that in green. Our quadratic shape is our asymptote there. It's a quadratic type asymptote. You can see that as the graph goes to infinity, we're getting close to, on this side, we're getting close to that line. And as as x goes to positive infinity, I'm going close to that parabolic shape. So because we call it an oblique asymptote, when our degrees are more than 1 apart, so when remember it's px over qx, if the degree of p of x equals q of x, then it's going to just be y is equal